problems, and also we are going to discuss about the region of convergence, zeros and poles as well. Okay, first one, let's look at the first one. The first one, we have x of n that is equal to 0.2 power n u of n plus 0.6 power n g of n. Okay, and here as you see, this is following a pattern a power n g of n. And now if you deal with the problem like that, then you have to pick up this pattern. Where is the a power n u of n? So here I'm seeing this. I'm seeing it over here. A power n u of n. And this is the C transform of this one. And this is going to be the region of convergence. Okay. The Z is greater than A. And let's copy this one down. 1 over 1 minus A power Z minus 1. Let's note this one separately here. 1 over 1 minus A Z power minus 1. Okay, that's the Z transform. And the region of convergence is Z is greater than A. Okay. Now this one also can be written as like if you want to get rid of this Z, you can also write it as Z over Z minus A. I just multiply Z on top and bottom, so these two cancels and you get Z over Z minus A. You can also replace like this. So now what you have to do is we have to so this is currently in a power n u of n. A is whatever the value we have here, and Z remains the same. So if I convert this one into Z transform, this is going to be Z over Z minus 0.2 for the first one, plus then the second one is Z over Z minus 0.6. This for the second one. Now as you can see, the region of convergence is, this is our ROC right here. Region of convergence is Z is greater than A. So for the first one, the Z is greater than 0.2. Okay. And for the second one, the Z is greater than 0.6. These are our A values. Okay. Just picking up from the pattern. So from this one, we can see that the region of convergence is greater than 2. So the region of convergence is exterior. If it's greater, that is exterior. If it's lesser, that's interior. So if you look at the circle of region of convergence, if you look at the graph, let's say this point, let's say this point is 0.2, and let's say this is 0.6. Okay, we are gonna have the first circle. I think I better draw it in the next page. I bring this one to the next page. I will have more space. Okay, here we go. Now first one with the radius of 0.2. If I draw a circle, draw it by hand. Okay, this is our first circle. The second circle. Okay, the first let's use different colors. The region of convergence of the first circle is exterior to 0.2, greater than 0.2, so it's exterior to 0.2, and it goes forever, like it doesn't stop right there, it goes forever, right? Entire Z plane, exterior. And if I draw the region of convergence of the 0.6, that is greater than 0.6, so it's going to be exterior like this. Okay, so in the region of convergence, the property of the region of convergence, if you have two outer circle, the outer of the outermost circle is going to be the region of convergence. So in this case, the outer of the outermost circle is the biggest one, the 0.6. So you better, like, this is the best one to express. If you just want to draw the region of convergence, this is the only thing you need to draw. The radius is 0.6. The region of convergence is exterior. And the region of convergence doesn't include 0.6 because it's greater than 0.6. It means it doesn't include the circle, just outer of that. Okay, this is our ROC. Now in the if you want to, and also, like, currently we have, this is our Z transform expression currently we have, but it's also better to express in such a way you can find the zeros and poles easily. So in order to do that, you have to simplify and bring it to one term, like you have to multiply and you have to find the common denominator. So here Z minus 0.2 we have in the denominator, and then Z minus 0.6. We take its common, then in the numerator we're going to have Z times Z minus 0.6 and then plus Z times Z minus 0.2. Now we can simplify this one. First one is going to be Z square and then 0.6Z right here, and then plus Z square again, then minus 0.2Z. In the denominator we are going to have Z minus 0.2, Z minus 0.6. I bring the calculation to the next page. Okay, if we simplify this one, Z square, we are going to have 2Z square. Okay, 2Z square, and then negative 0.6Z minus negative 0.2Z, we're going to have negative 0.8Z. And in the denominator, we are going to have Z minus 0.2 and then Z minus 0.6. Okay, and if you simplify this one further, we can take the Z common. So this is going to be 2Z minus 0.8. And in the denominator, we have Z minus 0.2. And then here, Z minus 0.6. So you know that the zeros are on top, whatever the values on top, the poles are whatever the values on bottom. So here the zeros we have is Z is equal to 0, and then if you solve for this Z is equal to 0.8 divided by 2, which is 0.4, and these are our poles. So we can say numerator is 0, numerator is equal to zeros, and then denominator is poles, and this one here is Z is equal to 0.2, that's one of our pole, and this one is Z is equal to 0.6, that's another pole. Okay, and that's it for this video. Like if you want to find the Z transform, that is right here, and the region of convergence, you can find the outer of the outermost circle. So this is our region of convergence, and then it's better to express in this way. We express in such a way that it's easier to, actually this is our final. We express it in such a way that it's easier to find the zeros and poles. Okay, this is our final answer. I hope you guys found video helpful, and also okay, I forgot, I have another question here. Let's solve this one. So here x of n is equal to negative 0.3 power n u of minus n minus 1 plus 0.5 n u of n minus 1. Let's solve this one also. Okay, I copied that question. Bring it here. Okay, this is our question. Now we have to pick up the pattern. Currently, if you just write the pattern here, we have in a form that x of n is negative a power n u of negative a power n u of minus n minus 1. Okay, this is the pattern we have. Now we have to look at the table. Does it match any pattern? Okay, it's right next to it. Minus a power n u of minus n minus 1. This is the pattern we have. Minus a power n u of minus n minus 1. And then that the z transform of this one is this exactly same like the before previous one, but only the region of convergence is going to be different. That's before we had z is greater than a. For this pattern, the z is less than a. Okay, so the region of convergence is going to be interior. So let's go ahead and convert this one. So since it's following the previous pattern, we have to just put it in a straightforward manner. We know that this is our a value, so the z transform is 1 over 1 minus a power z minus 1. This also can be written as z over z minus a as well if you multiply top and bottom by z. And the region of convergence is z is less than a. Okay. Now let's go ahead and convert this using z transform expression like this. So if you convert this one, then x of z is going to be z over z minus a is 0.3, and then plus z over z minus here a is 0.5. Okay, so that is what we have. Okay, well, that's what we have. Now let's go ahead and find the region of convergence. Region of convergence. Let me double check. Okay. Okay, so let's go ahead and find the region of convergence. Like before, we put the circle, and well, one of the circle is going to be 0.3 radius. The other one is going to be 0.5 radius. Better draw by hand. Okay, for the first one, the region of convergence is interior like this, because we see the condition, the region of convergence is less than a, which means whatever the radius we have, whatever the z we have, so for this one the z is less than 0.3, and then for this one z is less than 0.5. Okay, so this is for the smaller circle, and for the bigger one, the region of convergence is going to be the whole thing inside of it. Okay, and that one doesn't include the circle. That's all you have to know. This one doesn't include the 0.5, this one doesn't include the 0.3. Now the properties of region of convergence says the region of convergence is actually inner of the innermost circle. If it's outer of the outermost circle. So if it's interior, inner of the innermost circle. So it means the smallest circle is the only one. So it's better if you have to just express one diagram, this is the only one you have to express, this innermost circle. You don't have to worry about the outer one. So the radius of this one is 0.3. The region of convergence is whatever inside of it. Okay, this is our ROC. Now, so this is our Z transform and this is our ROC. Now it's better to express the Z transform in such a way that it's easier to find the poles and zeros. So again, we combine these two and make it simpler. To do that, I can copy the equation first. Let's copy this. So to simplify this one, you have to just take the common denominator, which is c minus 0.3, c minus 0.5, multiply on top c times c minus 0.5 plus c times c minus 0.3. Now, okay, this is c. Okay, z times c, z square, and then minus 0.5 z, then plus z square minus 0.3 z divided by z minus 0.3 times z minus 0.5. Now we can simplify this one furthermore, like combine the like terms. So 2z square we have here, and then minus 0.5 z minus 0.83 z, which is 0.8 z divided by z minus 0.3 times z minus 0.5. And if we take the z common on top, which is gonna give us 2z minus 0.8 divided by z minus 0.3 and z minus 0.5. And we know that numerator are the zeros and the denominator is poles. So we have a zeros, that z is equal to 0 and z is equal to 0.4 if you solve for z. And in the denominator we have the poles, which is z is equal to 0.3 and also z is equal to 0.5. Okay, and that is it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.